Unit 3, Lesson 2, Identifying Key Features of Functions. First, we'll look at intercepts. An x-intercept is where the graph crosses the x-axis. In a table, the x-intercept is when y is 0. The y-intercept is where the graph crosses the y-axis. In a table, the y-intercept is when x equals 0. Let's look at example 1, a graph. This is an exponential function. The x-intercept, look across the x-axis. The function never touches the x-axis, so there are no x-intercepts, so write none. Be sure to label x-intercept so I know if you're identifying the x or y-intercept. The y-intercept, here on the y-axis, the graph crosses at 0, 1, 2, 3, 4, at 0, 4. Let's look at example 2. Example 2 is a quadratic. For the x-intercept, look along the x-axis. We have a point here as well as here, so we'll actually have two x-intercepts. The first one, counting from the origin, is at -2, 0. The second ordered pair for our x-intercept is at +2, 0. For our y-intercept, again, make sure you clearly label your answers. Our y-intercept is here on the graph. So we will count 1, 2, 3, 4, 5, 6, 7, 8 on the y-axis. So it's 0, 8 for the y-intercept. Notice our function for the quadratic is in standard form, so the c value will be the same as your y-intercept value. Let's look at example 3. Our x-intercept is here at -2, 0. Our y-intercept is here at +4. So it'd be 0, 4. We cannot see that y-intercept in this form. This is called vertex form. It can identify the vertex, but it does not tell us anything about the y-intercept. Notice what the vertex is. It's the same as your x-intercept. So -2, 0 is your vertex. You could identify that from your vertex form as well. Let's look at some tables. Finding the x-intercept from a table, you will look for the y equaling a 0 and the x equaling a 0. Here we have x equals 0 in our table. For that ordered pair, if x equals 0, that would stand for a y-intercept. So 0, -3 is your y-intercept. Again, clearly label your x and y-intercepts. Think about if you graph that point. 0, -3 on a graph would fall 0 for the x-axis, -3 for the y-axis. It would fall on the y-axis, so that's why it's our y-intercept. The other 0 we see here for the y value would be our x-intercept, 2, 0. Let's look at example 5. This example is a square root function. We have a 0 in the table here as well as down here. One will be your x-intercept, or the other is a y-intercept. In order to be an x-intercept, you need the y to equal 0. So 4, 0 is the is the x-intercept. And then 0, 2 will be your y-intercept. the last example, example 6, a cube root function, we only see one point at 0, 0. But that is going to be both the x-intercept and the y-intercept. If you imagine the origin on the graph, 0, 0 passes through both the x-axis and the y-axis. So it's going to be your x-intercept and your y-intercept.